Hello everyone. Yesterday we have talked about the matter wave, that when any particle travel with the speed of light, it has a wave nature. Okay, we can compare it as a wave nature, and that wavelength is given by h by p, and that wavelength is known as de Broglie wavelength. Then we have also seen the fight between all the scientists that is going on, Newton, then Einstein, and all Maxwell. All the fight is going on. So that fight has been resolved by de Broglie. What he said, that light is a photon. Which is traveling as a wave. Okay, so there are some properties of a photon. You must see here. Rest mass of photon is 0. That means when photon is at rest, its mass is 0. And when it's accelerating, then it has some mass. Are you getting my point? So these are the properties that he gave for these photons, to explain these photons. What he said, the rest mass of the photon is 0. Photon conservation name. And then again what he said, that photon conservation is nothing. Photon can get absorbed, photon can get created. Are you getting my point? There is nothing like photon conservation. Are you getting my point? There is nothing like photon conservation. Photons are getting absorbed also, are getting destroyed also. Okay, there is a conservation of energy. There is no conservation of photon. We cannot charge any photon. Maybe there it is written in Hindi, but I am telling you, we cannot charge any photon. Photon is a chargeless. Photon does not have any charge, not positive, not negative. And even you cannot charge any photon. Are you getting my point? Photon is a particle which is not deviating by any of the field, neither by magnetic field, neither by electric field, neither by any field, electric field, magnetic field, gravitational field. Are you getting my point? No, by gravitational field it can, but by magnetic field and electric field it is not getting deviated. We know that photons travel with a speed of light, that is 3 into 10 raised to power 8 meter per second. So these are the basic properties, that its rest mass is 0, its travel with the speed of light, it is chargeless, and it is not getting deflected by any of the things, magnetic field and electric field. Okay, also photon conservation is nothing. Photon can be destroyed, absorbed, and all the things. Reflected. Are you getting my point? So these are the very basic properties of photon. Now one thing that we have to read is radiation pressure. What we have to read? Radiation pressure. So before that you must know about the intensity. Okay, you must know about the intensity, that what intensity is. So first we are discussing something about intensity and power, and then I will tell you the radiation pressure. I will give you a rough idea of what is radiation pressure. For example, this light is made of a particle. Light is having a momentum. Right now told na in de Broglie wavelength, that de Broglie wavelength is equal to h by p. What was p? P was momentum. What was p? Momentum. So this light particle is coming, yet striking my hand. These light particles are coming and striking my hand. Now they are getting either absorbed or reflected. I am able to see my hand. That means light from there is getting reflected into my eyes. Are you getting my point? Now if that light is having a momentum, very less, very less, but having, okay, so that light came, has collided with my hand and then coming back. So there is a change in momentum, and whenever there is a change in momentum, there is a force. I am not telling you. Who said this? Newton. Newton has said that whenever there will be a change in momentum, then there will be a force. What is force? Force is a rate of change of momentum. So due to that force, there will be a pressure created here. Okay, you are not able to feel it. Light is there. Light is striking my hand. From these three sources, there is a light. So that light is coming and striking my hand. There is a pressure due to this light, and we cannot feel that because it is very less. Okay, but if you measure it, it is having some value, and that pressure is called radiation pressure. And if you know about the intensity and power, this radiation pressure is very easy, very easy. Okay, by just reading this name, radiation pressure, it is coming that it must be some difficult. No. It is very simple. Okay, so just concentrate what I am telling you. Okay, so first we will see about the intensity and power. What is intensity and what is power? We already know what is power. Power is energy per unit time. What is power? Power is energy per unit time. Okay, if I will write here, we know that power is nothing but energy per unit time. Okay, this is your power. Everyone knows. You are reading this from class 9th, work, power, energy. Okay, again in class 11 there is a chapter work, power, energy. So you know what is power. Power is rate of doing work. Rate of doing work. How fast energy is getting consumed or energy is given. Are you getting my point? So power, what is power? Energy by time. And what is intensity? What is intensity? Intensity is energy given per unit time in per unit area. Okay. So if this is a light, so per unit area in per unit time, how much energy is falling? How much energy is sorry? How much energy is falling is known as intensity. Is known as intensity. See, intensity is energy upon area upon time. That means you can write as energy by time as power. So you can say power by area. Are you getting my point? What is intensity? You got the feel that per unit area per unit time in 1 meter square in 1 second how much energy you are getting. That is known as intensity. That is known as intensity. Is that clear? Okay, so here one example is there, one beautiful example is there. There is a point source. There is a point source. You can take it as a bulb. There is a bulb, point P, you can see. Okay, there is a point P, you can see. From there energy is coming out per second. Okay, that is constant energy is coming out. Now there is two surfaces. What I name it? I1 and I2. Are you able to see that? There are two surfaces, I1 and I2. Okay, so in which intensity will be more, in I1 or I2? So you will say that, sir, whatever power it is coming out is going in both. How much energy is coming out from I1 will go from I2. So sir, energy is same. Energy going in per unit time is same in I1 and I2. So what we have to see? We have to see the area. Now that same energy is getting distributed in larger area. So intensity will be less. You can say if there is a sound source, if you bring it very near, you will say yeah, intensity is more, loudness is more. But you will bring, when you will bring that very far, if you came very far off any speaker or any sound source, you will feel that okay, intensity is very low. Are you getting my point? So you can say that in I1 area is less, in I2 area is more. When area is more, your intensity is less. So you can say that I1 is greater than I2. Are you getting feel? What is intensity? 100% sure everyone, what is intensity? Energy per unit area per unit time is known as intensity. Energy per unit area per unit time is known as intensity. Very good. Okay, so now when you know, okay, we are not doing this. We are directly coming into the radiation pressure. Okay, so first we will build our very small concepts, and then we will add up and we will make something great. So one very small question, a very basic question I am giving you question here, and it is saying that in this area is given here, in this area, light is falling perpendicularly. In that given area, light is falling perpendicularly. Of intensity I and wavelength lambda. Okay, given, what is given? Area is given, light intensity I is given, and the wavelength lambda is given. What is asked? Find number of photons falling in T0 time. Find number of photons falling in T0 time. Just take screen, pause the screen and take 1 minute and attempt. Try to think, then I will tell you. I will surely tell you there is the answer behind this box. I will remove this box, you will get the answer. It is a 1-line answer, 2-line answer. So just think first. If you think, then I will tell you the answer. Okay? What are the things that is given? The area is given in which light is falling. The intensity of the light is given, that is I. And the wavelength is given, that is lambda. What is asked? Find the number of photons falling in T0 time. Find the number of photons falling in T0 time. Whatever I have told you in the last lecture about the matter wave, about the energy, about the photon, remember that, apply here and you will get the answer. Okay, pause the screen and attempt. Let's see. See, okay, leave that. One photon is having how much energy? Hc by lambda. Hc by lambda. I told you now that what de Broglie wavelength, what de Broglie said that light is a photon which is traveling as a wave, and energy of that photon is given by Hc by lambda. So for energy of one photon is Hc by lambda. Okay, energy of one photon is Hc by lambda. We have to calculate how many number of photons are fallen. So let the number is n. So total energy will be nhc by lambda. What we got? Total energy. What we got? Total energy. Now if I want intensity, what I will do? Total energy upon area upon time. What is area? A. What is time? T naught, which is equal to I. Simple, one line answer. Energy upon area upon time is equal to your intensity. Energy per unit area per unit time is your intensity. So what we want n. So just take everything there. So n is equal to IA lambda T naught by Hc. IA lambda T naught by Hc. Hooray! We got the same answer. Are you getting my point? Is it difficult? No. Very easy. Very good. Next for you. Again, I will give you the time to attempt. Don't see the answer. Okay, again. Now light is not falling straight, light is falling in an angle theta. Theta is given from vertical. Area is A, theta given. Find number in same question is given, same question is same. Intensity I and wavelength lambda is falling. Intensity I and wavelength lambda is falling. Find number of photons falling in T naught time. Find number of photons falling in T naught time. Pause the screen and attempt. I already told you one. Now this you have to do by yourself. Attempt it, everyone. Attempt it. AC is also not working. I will show you the board only. गायब हो गए. Hello. So we can also do what we have done right now is energy upon area upon time is equal to intensity. Okay. So when we have to find number of photons, what we can do? Total energy upon energy of one photon. What we will get? Total number of photons. See here what we have done. N into energy of one photon Hc by lambda is equal to total energy we have taken IAT. Intensity into area into time. You will get total energy. What you will get? Total energy. And what you want? You want number of photons. So what you have to do? Total energy upon energy of one photon. What you will get? Total number of photons. Yeah. Very easy. Sir, we will apply this same thing here. Now, here when light was not coming straight, light is coming in some angle, tilted angle, making an angle theta with the vertical. Then here, what is changing? Area is changing. Your projected area is changing. Now your area is not A. Your area is this. This one is your area. Are you getting my point? And that area is A cos theta. If this angle is theta, that means this angle is also theta. And if this is A, this is your right angle triangle. In a right angle triangle, if this is theta, this is A, then this one will be A cos theta. So in the previous question, instead of A, just write A cos theta and you will get the answer. So see how I am writing. Intensity is I, area is A cos theta, into time is T naught. What we got? We got total energy. What we got? Total energy. Now if you divide this by energy of one photon is hc by lambda. You will get the number of photons. Easy. 100%. Okay, let's move forward. Okay, so done this. Now whenever light is falling into one surface, okay, we are taking two things. Either that photon, there are many number of photons that is striking into any surface. Now two things will happen. Either it will get absorbed or it will get reflected. In both the cases, your radiation pressure will be different. So let's come into the radiation pressure. Now you know the basics and we can solve these questions. Radiation pressure. So whenever light is falling into any surface, two things is happening, either absorption or reflection. Okay, in both the cases, what will be the radiation pressure we will see. Okay, you will only calculate, I will only help you. So let's see. So here we are defining two terms, absorptive power and reflective power. Okay, so what is absorptive power? Absorptive power is energy absorbed upon energy incident. Okay, for example, 100 joule of energy is falling into any surface. For example, this is a surface and 100 joule of energy is falling. Okay, out of which 50%, 50 joule is absorbed. Okay, so how much energy is absorbed? 50 upon how much energy has fallen? 100. Okay, so 1 by 2 will be your absorptive power, If 100% light is getting absorbed, you have given 100 joule of light and photons and 100 joule of photons is absorbed, nothing is reflected, then what you will say? Absorptive power is 100 upon 100, that means 1. So for pure absorptive substance, your absorptive power is 1. Are you getting my point? Now, the rest one that is getting reflected, okay, so reflected energy upon total incident energy is known as reflective power, okay, reflective power and absorptive power. Energy reflected upon energy incident is reflective power, energy absorbed upon energy incident is your absorptive power. Are you getting my point? And total energy absorbed plus energy reflected is always going to be equal to total energy. So always your A plus R is always going to be equal to 1. Okay, for pure absorptive, A is 1, R is 0. For pure reflective, R is 1, A is 0. And for when something is getting absorbed and something is getting reflected, at that case, A plus R is always going to be equal to 1. Okay, so now first we will see all this. I've already told you. Now pressure for pure radiation, for pure absorption. Now what we are thinking is, we will do three cases. First, when complete energy is getting absorbed, at that time what is the radiation pressure? Are you getting my point? When energy is completely getting reflected, at that time what is the radiation pressure? And the third case you will do, I will only tell you the two cases how to solve, and then third case you will do when something is getting absorbed and something is getting reflected. Are you getting my point? And we will not do anything new. What do you want? Just tell me, what do you want? Pressure. What do you want? Radiation pressure. Just forget about the radiation. Just concentrate on the term pressure. What do we want? Pressure. We know that pressure is force upon area. Area will be given. So what do we want? Force. So our target, our aim is to find the force. What force a light is applying on any surface. Okay. So how we will find that? From Newton's second law. That force is equal to rate of change of momentum. And also, if continuously something is falling per second, something is falling continuously with the same intensity. Okay. So what you will say? To find the average force, what you will say? The total change in momentum in 1 second. I'm again telling you, just any space is there. Let me take any rough. Okay, so here I am saying you that force is change in momentum upon time taken. So whenever we are taking average Average, what we are calculating? Delta P in time 1 second. When time is 1 second, in 1 second, every second continuously when something is striking, okay, force is applied. So when we want to find the average, what we will find? The change in total momentum of the particle that is striking, change in momentum in 1 second. Total change in momentum in 1 second. When time will be 1 second, you will get F average. Are you getting my point? So from here we will find F average, force average, and then we will divide it by area. So we'll got pressure, radiation pressure will be F average by area. Are you getting my point? What we are going to do, I told you. Now you will do. And I will tell you, don't worry, I am here with you. I am here with you. Are you getting my point? Okay, although because of this all coronavirus, we cannot connect face to face. Okay, because of your security, your precautions also, and for my also, we cannot connect face to face. But I am here. I will be taking live classes also, where you can connect with us in YouTube through live classes. You can comment, you can ask the question at the same time, and we will fix a time for that. Okay, so we are going to give you all that. We are going to give you the face to face. Nothing will be different. Only there you have to come. You have to sit in the class. Here you can just see all this crash course either in your phone or in laptop. Are you getting my point? So now, in case of pure absorption, okay. So see here what it is telling. A light is falling of intensity I in a surface area A, having wavelength lambda, speed c, frequency f, and absorptive power is 1. Absorptive power is 1. That means all the light that is falling is getting absorbed. What it is has asked? Find pressure. Okay, I will give you time to think, then I will tell you. Don't worry, I am here with you. I will tell you. First you think, okay, because I told you everything, how to calculate pressure. Pressure is force upon area. Force, how you will calculate? Average force. Average force is change in momentum in 1 second. Change in momentum in 1 second. How many particles are falling? I already told you. So all the pieces I already explained you. Now you have to assemble it. Now it is just a child's game to do this. So I am giving you 1 minute. Just stop the screen, pause the screen, and attempt this question, and then I will tell you. See the screen if you want. Only screen. I have disappeared. Ooh. Okay, let's start. Okay, just see. I already told you that F average we will calculate by change in momentum in 1 second. Change in momentum in 1 second. Any doubt? Any doubt? No? Sure? Okay? Okay, now change in momentum. What we will use? We will use de Broglie wavelength. What is de Broglie wavelength? Lambda is equal to, what is de Broglie wavelength? Lambda is equal to h by p. What is p? Momentum. So here we get momentum is equal to h by lambda. Momentum is equal to h by lambda. Now we will calculate initial momentum. Finally momentum is 0 because it is getting absorbed. So change in momentum will be initial minus final. Initial momentum, pi, initial momentum is h by lambda. Initial momentum is h by lambda. What is the final momentum? Final momentum is 0 because light is getting absorbed. Light is absorbed. Now it is having no energy. It is not moving. It is not having any momentum. It is not having any momentum. So what is the change in momentum? Change in momentum is h by lambda. Minus 0 is h by lambda. This is the change in momentum of one photon. This is change in momentum. This is change in momentum of one photon. We have calculated change in momentum of one photon. And we already know in 1 second how many photons are coming here, or in t0 time how much photons are striking. How we have calculated it? Just remember how we have calculated it. What we have said, total energy, intensity is I, area is A, intensity is I, area is A, time is 1 second, upon energy of one photon. Energy of one photon is hc by lambda. Hc by lambda. This is the number of photons. I already explained you how to calculate this. Total number of photons falling in T0 time. So instead of T0, what we have written? 1 second. What we have written? 1 second. Now, total in 1 second, how many photons are falling? We know that also. And what is the change in momentum of one photon? We know that also. So calculate the force. So to calculate the force, what we can do? To calculate the force, we can say that to calculate the force, we can say h by lambda, change in momentum of one photon into total number of photon is Ia lambda by hc. Lambda and lambda cancelled out, h and h cancelled out. Answer came is Ia by c. Is this your answer? No. If this is a force, what we have to calculate? We have to calculate pressure. So pressure, what we have to do? We have to divide it by A. When we will divide it by A, our A will get cancelled out. Our answer will come only I by C. So when energy is getting absorbed, 100% energy is getting absorbed, and light is coming very perpendicular to any surface. At that time, radiation pressure is I by C. At that time, radiation pressure is I by C, where I is intensity of light that is coming. I is intensity of light that is coming. And what is C? C is the speed of light. 3 into 10 raised to power 8 meter per second. Are you getting my point? So we have done this for absorptive. Okay. Now again, I will give you one question. If it is 100% in the same question, okay. Okay, take it. In the same question, instead of A is equal to 1, I am saying R is equal to 1. Find pressure. Okay, do it. In the same question, everything is same. Instead of A is equal to 1, I have given R is equal to 1. Now 100% of the light is getting reflected. 100% of the light is getting reflected. Find pressure. After this, we'll go into the next topic. Yes. Just do it. Let me disappear. Andhera कायम रहे. You will say, sir, you are not doing this much comedy or something like this, mad type of things in class. Okay, so let's start. Sufficient time I have given you. Sufficient time. It is recording or not? Yeah, it's getting recording. Okay, recorded. Now, what will be the change? Initially, momentum is same in both the cases that we have done at that time and now. What will be the change? Now momentum is there. Final momentum is also there in opposite direction. Okay, initially when it is coming here, now it is going there. Same momentum is there, but initial case what is it is happening? Final momentum is 0. This time final momentum is not 0. Initial momentum was see here. What was the initial momentum? Initial momentum was h by lambda. H by lambda. Now final momentum is also h by lambda in opposite direction. So what I am doing? Minus sign. Are you getting my point? So what will be the change in momentum? Change in momentum. H by lambda plus h by lambda. It will be 2h by lambda. It will be 2h by lambda. Now change in momentum is 2h by lambda. Okay. Now change in momentum is 2h by lambda. How many number of electrons that photons are striking any surface? That will be same. That will be same. How much it has came? IAT is 1 upon hc by lambda. Are you getting my point? total energy upon energy of one photon. I am again telling you again and again same thing, total energy upon energy of one photon, IA lambda by hc. Just multiply it, you will get the force. For force, IA lambda by hc into, this is number of photons into change in momentum of one photon, 2h by lambda. Lambda and lambda cancelled out, h and h cancel out. It is coming 2IA by c. So pressure, we don't need force, we need pressure. So pressure will be force by area. So 2I by c. So when light is getting reflected, at that time radiation pressure is 2I by c. When it is getting absorbed, it is I by c. And if something is getting absorbed and something is getting reflected, you can calculate what is the pressure due to absorption and what is the pressure due to radiation. You can add it. Pressure is a scalar quantity, you can directly add it. Are you getting my point? Yes or no? Is it clear? What is radiation pressure? Clear? Okay, next thing is very important. We will study photoelectric effect. What will we study? We will study photoelectric effect. One question is sure from in every, either you are preparing for medical or IITJEE, one question is sure from that. So we will study photoelectric effect in next class. Tada, bye bye. Just be safe. Take precautions. Don't come out of your home. I'm again saying you don't come out of your home. Please break the chain. Please become little bit serious about this. This is not a very casual situation. You can already see in other countries how this case is becoming, the number of deaths and all. So please be careful, wear a mask, and just wash your hand regularly, and please be safe, okay? And study. You got a time because JEE mains exam is also getting postponed. The new dates haven't came yet, but it will come by 31st, I think. So just you do by yourself, whatever you just do is take care of yourself and your family, and also study at your home. We are there for you every time, whenever you want, okay? So tata, bye bye, take care.